everyone, we're going to find the Maclaurin series for f of x and find the associated radius of convergence. So we're using this form here. We want it to equal the sum n equals 0 to infinity f, the nth derivative of 0 divided by n factorial times x to the power of n. So what we're going to do is crank out some derivatives. So if we have n here, if we start at 0, and that's meaning this first term, we're going to have, let me just draw a line here. So we'll have f of 0, which equals e to the power of negative 2x. And evaluating that at x equals 0, this equals 1. All right, and then let's try the first derivative, f prime of 0. That equals negative 2e to the power of negative 2x. Evaluate this at x equals 0. This gives you negative 2. Now let's let n be 2. So the second derivative of f with respect to with 0, that's going to be 4 e to the power of negative 2x. Evaluate that at x equals 0. We get 4. All right, and let's do another one. You start seeing a pattern. Evaluate this at x equals 0. We're going to get negative 8. So the next one is going to be 4. So let's put 4 here. That's just going to be positive 16 e to the negative 2x power. And then we have evaluated x equals 0. That gives you 16. So you notice we keep, our function stays the same here, but we keep multiplying by negative 2. So what we have is our series is going to be the sum n equals 0 to infinity, and we multiply by negative 2, so it's going to be negative 2 is your x to the power of n divided by n factorial. And so that's it. And now we have to find the associated radius of convergence. We're going to use the ratio test. So let's go ahead and write this again. With the sum n equals 0 to infinity, negative 2 to the power of n divided by n factorial, and then times x to the power of n. So we're going to take the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. So this is going to equal the limit as n approaches infinity. And for our numerator now, looking at this, we're going to get negative 2, and then you're going to write n plus 1. And then for the x, we're going to have times x to the power of n plus 1. And this is divided by n plus 1 factorial. Now we're dividing by a sub n, which is the same as multiplying by the reciprocal. So this is going to be times n factorial divided by negative 2 to the power of n times x to the power of n. Absolute value. Now looking at this, let's simplify as much as we can. This is going to equal the limit as n approaches infinity. Now let's look and see what we have. For our n's here, if you have x to the n plus 1 minus n, so that's just going to be x. I'll just put absolute value of x here. So that we took care of that. Let's take care of this. This is just going to be absolute value of negative 2. It's the same thing. Negative 2 to the n plus 1 minus n. So that's going to be, the absolute value of negative 2 is positive 2. And let's look at these two right here. So this right here can be written as, let's see, this one right here can be written as n plus 1 times n factorial. Remember, this is like n plus 1 times n minus 1. And wherever you stop, you put the factorial. We just want this one, so the n factorials will cancel. So all we're left with the denominator is n plus 1. So when you substitute n for infinity, this is going to equal 0. Since it's 0 and it's less than 1, for all x, that means our r equals infinity. All right, so it's divergent. Thank you. Have a nice day. Bye-bye.